binding energy per nucleon increases with mass number up to a peak near iron and then slowly decreases as nuclei get heavier, which makes medium mass nuclei the most tightly bound, and explains why fusion of very light nuclei and fission of very heavy nuclei release energy. Think of nuclei like clusters of magnets. When small clusters join, they stick together more tightly, and each particle feels a stronger pull, so the energy holding each particle in place per particle goes up as the cluster gets bigger. This rise continues until you reach nuclei around iron, where that pull is strongest per particle, and after that, adding more particles makes the per particle pull a bit weaker because the forces do not scale perfectly and electric repulsion between protons becomes more important. For very light elements, smashing them together into heavier ones releases energy because the new nucleus has higher binding energy per particle, and for very heavy elements, splitting them into smaller ones releases energy for the same reason. The curve that shows binding energy per particle versus mass number is smooth and peaks near iron, which is why iron group nuclei are especially stable compared with both lighter and heavier nuclei. Students often think heavier always means more stable, but the key is binding energy per particle, not total mass. So remind yourself to compare per particle values rather than total binding energy. Another common mistake is ignoring proton repulsion in heavy nuclei, which explains the slow decrease after iron. So remember, electrostatic repulsion grows with more protons and reduces per particle binding. Some people confuse fusion and fission directions for energy release, so keep straight that fusion of light nuclei and fission of heavy nuclei both move products toward the iron peak and thus release energy. For more videos and clear explanations on this topic, check out www.gumballdegree.com.